Hello everyone, my name is Achita Vetagiri and my teammate name is Sai Krishna Bhavani Reddy. Today we are going to give a presentation on essay score prediction. Before going to introduction, here are the contents we accomplished. These are the timelines. On July 15th, we did data selection and understanding. July 18th, data preparation and vectorization. July 22, machine learning models. July 28, reports and presentation. Today we are going to explain about ML models and after that we are going to submit our report. Introduction. In the past, instructors had to correct so many essays and he has to go through each and every essay. It is time consuming. And secondly, we all hear that some students to earn high grades while the other students receive bad ratings despite the fact that both groups of students have written well. As a result, in order to solve these problems, I designed an automated essay grading system that is based on machine learning to work in conjunction with the automated evaluation system. Keywords: natural language processing, NLP, machine learning, bag of words, essay score, automated essay score, reached algorithm, linear regression, decision tree. We will go through all these words in the below slides. Objective: our main objective of this project is to undertake a comparative analysis of several machine learning models using supervised machine learning algorithms. Models include rich regression and decision tree were examined as part of this project. These models were trained using the essays that were submitted to the researchers as part of a labeled dataset. This evaluation was conducted using the training and testing variance score, root mean squared error, mean absolute error, and R squared error score. So today we are going to see all these three reached linear regression and decision tree, and we use a data set consists of so many essays. We train with the data set, and after that we are going to find the values of variance score, root mean square error, mean absolute error, and R square score. After that, we are going to compare all these three models. The fact that certain automated essay grading systems depends on relatively simple criteria such as the number of words and paragraphs in an essay as well as the average length of the sentence is the primary factor that contributes to their lack of accuracy. This project's objective is to create a computerized grading system that evaluates essays based not just on their format but also on the content of the ideas they include. We all know that before we already have a certain automated essay grading system. Those system will grade based on number of words and length of the sentence. This may show some lack of accuracy because if the essay is good, even the essay is good and it has a good related to the question, but with less words, with less sentence, it will give the grading very less. So to solve this problem, we created a computerized grading system. It doesn't evaluate the essay based on the number of words or the length of the sentence. It evaluates based on the content of ideas it includes. Natural language processing. Natural language processing will be utilized in this project. The processing of natural languages makes use of a variety of methodologies, including statistical, supervised machine learning, rule based, and algorithmic techniques. The essential tasks of natural language processing include word sentence segmentation, lemmatization, normalization, parts of speech tagging, syntax parsing, and many more. Because of this, natural language processing is able to have applications in the real world in a wide number of fields, including the teaching of languages. Coming to methodology, dataset and cleaning. This is natural language processing project so the data was of textual type with a target feature name manual score that was the score assigned by professors to different essays. There were 12,978 essays in the dataset. With respect to cleaning, I dropped the duplicate values first of all and then checked missing values in the data and found that there was only one record having missing values. so I dropped it. So this is the example of our data set. These are the essays and these are the scores. These are manual scores given by professors. Each essay has each grading. So we have total 12,978 essays. So of then I dropped the duplicate values first. So I dropped the duplicate values and I also dropped the null values. After that, I took each essay with unique grading. After that, to clean the text, I done following things to the textual data. Removed punctuations, lowered the text, removed stop words, lambdized words. So here are the comparison of cleaned and uncleaned data. I'm going to say one example. Dear local newspapers, comma, I think affects computer. You can see here the capital letter D turns to lowercase small d, dear local newspaper, and there is no comma over here, and there is no I letter, think affects computer. So you can see here the data, the clean data has only important words rather than everything. So this is unclean data and this is clean data, what we did. So then after that, I made word clouding for the clean data. This is the word clouding. You can see here there are so many words in this cloud. Also, person like one. You can see here it's like highlighted words, which means it used repeatedly in our essays. So some other words like empire state, state building, even, organization, these are some words are used again and again in our essays. In the end, I applied bag of words to encode the textual data into integers, integer values, because machine learning models cannot directly work on textual data. We need to convert it into vectors, and for that, there are many techniques available for vectorization. I used simple techniques that was bag of words and generated the vectors for text and separated data into two parts. First part was training and it was the 80% of data, and second part was testing data, that was 20% proportion of original data. Building model. In this part, I built three models, trained them, and accessed their performance using multiple evaluation metrics. I trained them separately and made a consecutive functions to evaluate the models, and then after training that model, I evaluate it using that defined function. Here are the models we used: reach, linear regression, decision tree. So you can see here we use this model and and we evaluate an essay. So the graph look like this. This orange one indicates predicted grade and blue one indicates original grade, means manual grade. So you can see we find out the grading system using rich linear regression and decision tree. And the root mean square of error here 3.75, mean absolute 2.39, R2 square 0.83. In the same way, I trained it on training data and tested on unseen test data, and I got following results from this model. So in linear regression, root mean square is 3.75, mean absolute error 2.39, R2 score 0.83. So coming to decision tree, I got these output. Root mean square 3.28, mean absolute error 1.51, R2 score 0.87. So now we are going to compare all these three models. When I evaluate all the models, I came to know that decision tree was performing better than any other models with an R2 score of 87%, that is good score. Here is the comparison of all the models. You can see that the training score for all these three is 0.88, 0.88 and 0.99. So for testing score, these two have 0.80, 0.8312, 0.87. So you can see here the decision tree values are approximately giving best results than linear regression and feature regression. The testing and training scores are uh, performing very well, and the auto score and all these errors having uh, very less in decision tree and very high in linear regression and region. Conclusion. This was an NLP project in which I used textual data of student essays, and the main purpose was to build the automated essay grading system. So, first of all, I explored the data a little bit and then cleaned the text from unnecessary details like punctuations, stop words, and did lemmatization. After that, I created vectors from text using bag of words. Then I made three models and evaluated them and found the decision trees best from all these models. These are the reference. Now my friend going to give an explanation of the implementation. Thank you.
Hello everyone, my name is Krishna. Today I'm here to explain the code part of my project. So, coming to this code part, here I have imported all the important libraries that I need for my projects, like the NumPy, Pandas, Seaborn, Matplotlib, Sklearn, and all. And here I tried to remove all the warnings. Uh, Sorry. So, I have read the data set which I use for my project. This is the Excel data set. So I can show you the data set. So this data set has been I have downloaded it from Google. So these are the columns which we have: SID, essays, manual score, prompt, and some like empty. And like I did not modify anything on this thing on this Excel file. So each column has each row has one essay. So this is essay in the first line, and this is the second essay, and this is the third essay. So like that we have a lot of essays here. And you also have a manual score which has given by some professor for each of this essay. So here we are only using these two columns. We are not considering this prompt, this empty, or this essay id column. So we are not using them. We are only using this manual and essay column. So here I have tried to display the shape of the data. I'll show this thing when I execute my code. So here first I have tried to display the shape of the data. So the shape which shows the rows and number of rows and columns, and also the data type of the rows and columns. And also I have displayed the statistical properties of the data here. And then after statistical properties, this shows the like the total number of things in the uh, like column. And also it finds the mean, median values. It also shows the maximum and minimum values column. So then I have dropped the duplicate values, and I have also dropped the null values from this column manual scores. So like uh, I can show you like so here this is the manual score column. If there are any boxes which doesn't have any score, like which essay is not scored, like it will be empty. And such kind of null values I have deleted complete row. And then I also dropped the unnecessary features like this this unnamed column which we are not using. I have deleted this complete column also. And then after that I have started this data cleaning. So in this data cleaning, so what I have did is I have taken the data which we have uh, read. So the text data, I have removed all the numbers, symbols, comma, punctuations, and all. I only considered the letters, words, which consists of alphabets. Then I have made them into lowercase and split them. So after splitting, I have iterated each word and tried to find all the stop words that are present in the text data. So the stop words are nothing but the words which are used to connect the sentences or connect the words, such like is, and, or, the, of. All these words are stop words. These words doesn't have any meaning. Mm, so I have removed all those words and only considered the meaningful words. And then from those words I have tried to lematize them. So for lemmatizing I have used lematizer.lematize function. So lemmatizing is nothing but finding the base word of the words. Like if there is a word called teach, teaches, teaching, teached, which is repeated multiple times with a different tense. So all those are considered singly as a base word teach. So if we don't do this limitation, it will think teach, teaches, teached, all those are different words, and it will consider each one as a single word. But after doing this limitation, it will consider all those words as has the same meaning, and it will count every, like it will count them as like the three, the teach is repeated 3 to 4 times, like that. So after that I have joined them all the text, all the words. So I have converted them into string. So then, so after cleaning the data, I try to form the word cloud. So in this word cloud, first I have taken all the stop words, and also I have taken this the cap. I considered this as stop word. Cap is nothing but, I will show you here. So here you can see in each essay the caps word is repeating multiple times. This is there in every essay. Like this cap is nothing but wherever there is a person name, so they remove the person name and mentioned it as cap. So cap and cap 3, so it is like it is a person's names. So caption, so instead of person name they mentioned as cap 2, cap 2, and cap 3 is then another person name, cap 4 is another person. So like that, so I have removed all those things. Like I have considered them as stop words so that I can remove those words. And then I iterated the text and converted them as splitted them as tokens. So each token now is converted into lowercase, and then I joined and showed like in the word cloud format. So this word cloud format is an image. So these are the dimensions of the image. I'll show you that image while running my program, executing my program. And then, so this will display the image of the word cloud. So after I have also stored the data into data variable so that it will be safe, like even though if I modify this thing. So now after cleaning the data, now I try to vectorize the data. So vectorization is nothing but nothing but converting all the textual data into numerical format, because machine learning models will not understand the textual data. So we need to vectorize it to convert into numerical data which can be understood by the machine learning models. So here I have used bag of words technique for iteration. There are multiple ways to do iteration, but I use bag of words. So here I have separated the input and output features. I have stored this count data into X and also stored this manual scores into this Y. So here after that, like I have imported the SK learning models. So I'm going to use this linear regression, ridge algorithm, and decision tree regression, all these three models to find the grading. So I'll find the grade of this essay using each model, and also compare the way each model is working and which is doing good in grading the, which is grading more accurately. And now I have taken some empty uh, lists, like the train score, test score, root mean square value, mean absolute value, square scores. So here you can see the evaluate model. Here I have tried to predict some values that and stored in y, and use this x and y values, the training values. So here I used 20% of the I separated 80 and 20%, and I used it one for the training and other for testing. So so this by using this x train y, like by using this x and y training data, I find out the uh, training score, test score, root mean square value, mean absolute error, r square value. So all these scores are appended into this list, and then I use this print to print on the output window. So I'll show you this while executing the code. So it will show the root mean square error, mean absolute error, r2 error. So these are used to compare all these modules and find out which is good. And also it will also print the graph. So now, so here we got the linear regression here. So the data after by using this linear regression, we I found some data and then passed the data into uh, evaluate model. Though this evaluate model will find all these values for the training score, test score, root mean square, and r square values, and display. And also the same thing with reach. I use this reach model to grade the essays, and then that I pass that values into this evaluate model, and the same thing with the decision tree also. So let me execute my code now. So here you can see. So first I have showed the shape of the data. This is the shape of the data, which consists of some rows and columns, which has been displayed. And also it showed the data type, this object float and float for the columns which are present. And also the statistical properties. Here I have displayed the statistical properties, so it's showing the statistical properties. So here it showed the count, essay count, and manual score count. Essay count is like 12978 and manual count is 12977. That means, so one essay is not scored, then the box is empty, so that's why it did not count. So I have removed all such kind of data, like all such kind of empty data here. So here it shows the maximum score that is given is 60 for an essay, and minimum score that is given is 0 in this data set. So and then now coming to this word cloud, which I said. So this is a word cloud where we removed all the numerical punctuation, numerical values, punctuations, and stop words, and then all the rest of the words are displayed here. So the words which are shown in the bigger format are those words which are repeated very multiple times, and the words like Empire State, VA, state building, these are repeated some like pretty number of times. And the words which are shown very small, those are repeated very few number of times. So this is how like it will analyze the words which are repeated multiple times and like the meaning of the words and all. So after that, now by using these words which we like passing these things into this linear regression, like by using this linear regression, we got the grading. So the original grade which is given by the professor, which is already existing in the data set, is taken in the blue color, and the predicted grade by the linear regression model is taken in the orange color format. So here we can see they are almost similar, but here sometimes the predicted grade is higher than the original grade, and sometimes, yeah, like sometimes the original grade is higher than the predicted grade in the linear regression. So uh, like this is a ridge model. This is by the predicted grade using ridge model. Here also, like it almost did same, but the same thing happened. Like there are some changes, but it's doing good. And this is decision tree. So this decision tree is also trying to like find the grades. So like they they're like they are not more accurate, but they're good at grading. uh, so when I compare all these three things, the values of these three for the linear regression, we got the root mean square value is 3.9, the mean absolute value is 2.3, the R2 score is 0.80. And for ridge model, we got the root mean square as 3.9, mean absolute value is 2.3, R square is 0.80. And for decision tree, we got the root mean square is 3.6 and mean absolute 1.6, and R2 score is 8.2. So here we can find that R2 score in these three models. Decision tree has a high R2 score 0.82, where they have 0.80, 0.80, and the error is the minimum in this decision tree, like 3.6, but they have 3.9 and 3.9, and also the mean error has 2.3, 2.3, but here it is 1.6. So after comparing these three models, we can say that our decision tree is working good for grading, because the errors are 3.6, 1.6, which is lower than the error for linear regression and ridge, whereas they have 3.9 and 2.3, 3.9 and 2.3. This has 3.6 and 1.6, so the errors are less, and the R2 score is 8.2. And for these two, we have R2 score is 0.80, and the R2 score for this is 0.82. So the R2 score is higher, so for decision tree. So here we can say the decision tree is performing good compared to this rigid and linear models. Thank you.